Hey guys, Shan this side, welcome back to the channel. So today in the first video of Spring AI, we are going to see what is LLM, what is GPT, so that we are all on same page. And before we start, one more thing I want to say that we are not going in depth of LLM because the major focus would be on integrating our application with LLM. Okay, so major focus is here. How we can integrate, how we can fully utilize the capabilities of LLM like generative AI, all capabilities, how we can fine tune this LLM based on our application needs. So this is the major goal here. Okay, not like within LLM we have to understand, change or something. No, like, so that's the goal I want to set before we start. So here in the LLM introduction and the GPT introduction, so I will try to explain my understanding in a simplest manner. Okay, but yeah, feel free to go in depth and if you further like to know about it. So let's start with this understanding. So what is LLM? LLM is large language model. So it's a model trained on huge amount of text data like Wikipedia, books, web tests, etc., which help it to understand and generate human-like language. Okay, so this is something which we all know that it is trained on a huge amount of text data. Okay, so there are different LLM providers in the market. Like for OpenAI, we have multiple GPT versions as of today. Then we have Anthropic, we have Claude 1, 2, 3 different versions. Llama 2 and Llama 3 from the Meta and Gemini from Google. So there are different LLM providers today we have, and we have lot of options. We can choose anything which we wanted, but I will keep major focus on the GPT-1. Okay, so GPT stands for Generative Pre-trained Transformer. Generative means something which can generate content, or you can say that which can generate text, okay, or any other content like image, voice, etc. So in a simple way, you can define generative as something which can generate text or other content like image, voice, etc. Then the second is pre-trained. Pre-trained means it's already trained on massive internet data. So these two are very pretty clear. And the third is transformer. This is very important, or you can say that this is the fundamental or architecture of GPT actually. So this is the neural network architecture it uses, transformer. So I'll try to explain transformer in a simple way, what I understand. Okay, and let's see, you will find this interesting. So there are two phases. In the GPT, you can say that it has two phases. One is pre-training phase, means it's a learning phase, and it learns through massive data set like code, your book, Wikipedia, all these things. So generally this phase is known as pre-training phase. And there is another phase called inference phase, means the model is now trained. Okay, so it's like pre-trained model. Now it is ready to generate response. Now I try to divide the functionality of transformer into simple 4-5 steps. Let's see that. Step 1. Input text is broken into tokens. Let's say that this is the input I gave. Apple a day keeps doctor away. So in the step 1, what transformer does is it breaks the sentence into tokens. Okay, like this is my one token, apple, then this is another token, a day keeps doctor away. So these are all different tokens. But one thing, please note that each word is not equivalent to one token. Let's say in the second example, I keep Apple makes extraordinary phones. Now here if you see, it divides the one word extraordinary into two, extra and ordinary. So just wanted to show you with an example that each word doesn't mean that it is one token. Even sometimes a single word can be divided into multiple tokens. Okay, so first thing is input text, whatever you will provide is broken into tokens. Cool. Now we move into step 2, compute static embedding. What is that? So here I told you one thing, that we have two phases. One is pre-training phase and one is inference phase. In the pre-training phase, it learns through massive data set. So it generates its vocab, or you can sometimes we call it, you can say that LLM vocab. Okay, so it has its own vocabulary, like different understanding about different tokens. It has lakhs of tokens which has created. It is stored in a file. Its vocab, which contains generally tokens understanding. This model, token understanding, which is called vocab, it is stored in a file. Okay, so from this file, okay, for each of this token, whatever the sentence prompt we gave, first step is converted into a token, and for each token, it check its vocab file, okay, and from its pre-understanding of the token, it compute the static embedding. Now what is this static embedding? Each token is assigned a fixed point in a multi-dimensional space. Okay, so for example, in a simple, very simple term, let's consider a 3-dimension. Okay, say this apple. So let's say this apple. So from its vocabulary file, whatever the understanding it has for apple, okay, it taken out this static embedding from that file. Okay, and currently it's 3 dimension. So here if you see, this vector has 3 values, 1, 2, 3. Okay, so consider this as a 3 dimension. Okay, x axis, y axis, z axis. Okay, now here if you see, in this 3 dimension, this point 1, second and third, let's say this point represent your 1 token apple. Okay, so this is just an example. So each token is represented in a multi-dimensional space. Okay, so for now I have only shown 3 dimension, right? But if you see the GPT-3, it has 12,288 dimension. For GPT-4, they haven't published on their site, like we don't know, but definitely it might be higher than this. So just see that for 1 token, in how many dimensions, you can say that dimension, I would say that different type parameters, or you can say that a lot of things considered, that what this model understand about this token. Okay, so it convert the each token into a number, which is, you can say, a vector sequence of this floating numbers. Okay, and how this for each token, how it got this vector from the pre-training. So in pre-training, it is, you can say that from huge amount of text, it got this learning. So for lakhs of token, it knows that, okay, apple, this is the vector. Okay, so, or in very simple term, I would say that consider this, that hey, you have apple. Now you have multiple, you can say that dimensions. For example, I'm just saying, for very simplest way, I'm just trying to tell you an example. Let's say red, yes, some number 0.1 something. Okay, round, let's say no, let's say minus 0.1 something. There are different, you can say that on different dimensions or different questions, you can say that this model try to evaluate this token. Okay, during pre-training, I am telling you, in the pre-training, when it is trained on a large amount of text, for each token, it has multiple things, parameters, dimension, you can say. For that one, it compute these numbers, okay, which it understand. Okay, now if it has 3 dimensions, like then it will vector have 3 values, 1, 2, 3. So currently I told you ChatGPT 3 has 12,288 dimension. So you can consider this a vector sequence of this many floating numbers. Okay, and that represent one dot, you can say that, in a multi-dimensional space for that token. So this thing is clear, right? How for each token it get a vector. So it's not something we have computed, it's based on the pre-training. Okay, so for each token, whatever we have, for each token, from its vocab, you can say that vocab file, it compute this vector, or you can say that that's why its name is called static, means it's already there in its file. Okay, this is what it understand. One thing I would also tell, see, apple could be a fruit, apple could be a the IT company name. So here it doesn't means that this vector is representing fruit or this vector is representing IT company. No, we don't know at this point of time. Okay, so it's, you can say that during its pre-training, whatever the content it has been trained on, okay, so much massive content. So whatever the knowledge it has built, okay, so it has that info. It could be fruit, it could be IT company, or it could be something else. We don't know at this point of time. But only thing is, we have some vector which is static, which is generated for each token at the time of training. Okay, and it has this vector for lakhs of token already. So first is so our step 2 is done, computing the static embedding for each our token. Now the step 3 is building contextual embedding. I told you in the static one, let's say this is apple and this is its vector. For example, something 0.1 comma 0.2 comma minus 0.3 something. This is something I got static. This could be apple, could be fruit, apple could be IT company, or apple could be anything which it understand at the time of the data it has been fed. We don't know. Now we have to improve it through contextual embedding. So for example, now see this token sequence. Apple a day keeps doctor away. Now if you read the complete sentence, you get one sense that, hey, we are talking about fruit. Here apple is fruit. Another sequence of token, if you read, apple makes extraordinary phones. Now here this complete sentence make you a good info that this apple is IT company. So now when you read or when you understand your neighbor tokens, then you get a better clearance like what exactly this token means. Okay, and that's where it is like building a contextual embedding. Contextual means now it, you can say that it consider its neighbor token. Okay, and it improve its vector. So whatever the vector it has earlier for apple, 0.1 comma 0.2, let's say 0.3, this is the vector 3D in 3D dimension. So only 3 sequence of number. So now when it improves it, when it reads the context, when it reads its neighbor token, now it know that, hey, this apple here in this, it's a context is fruit. So it will improve its vector. For this one, it said, hey, okay, this is an IT company. Then it's improve its vector. Okay. So for example, here in this dimension, it is mostly, let's say, all your software token, backend engineer, your IT company, let's say Apple, Oracle, these tokens are going this side. Okay, they are getting dots at this area. But fruits like apple, mango, orange, these all going at this. Okay, so earlier maybe it was somewhere here or somewhere here, we don't know. But based on the contextual information, it improves this vector and try to improvise those values, you can say that, so that it represent the correct relationship with the other tokens. Okay, you got it right? So now here read this. Till now all we have is a static vector for a token. Whatever during pre-training we got a vocab file, from that we just take out that okay, this token, this is the understanding, this is my understanding. Okay, and there is no context added to it. If you see below, I told you that even for apple, from one sequence of token it is considered as fruit, another sequence of token you will know it is IT company. Okay, but when it is static, it just represent same for both. So now in the step 3, what it does is it do self attention. Self attention means like listen. In this step 3, it does self attention, a layer which tells how to attention it need to be like how much attention you need to give to the neighbor token. So you have, these are the neighbor tokens for the apple. So for this token, how much attention I need to give to my neighbor token, that is called self attention. Okay, so based on that, so let's say now here apple, when it gives attention to its neighbor token, so now it's know that okay, doctor, maybe this is considered as fruit. Now it can comes to conclusion that it might be a fruit. Okay, so it updates its vector value to reflect this context. Similarly here apple, when it's check its neighbor token, okay, when it give attention to its neighbor, so it see that hey, phone. Okay, so it know that it might be we are talking about IT company. Okay, so it's update its vector value to reflect this context. So its vector value either move to a particular direction, you can say that. Okay, and this vector passes through multiple self attention layers. So it's not like only one time self attention layer, like just one time it goes. So it has multiple layers, it goes multiple layers, and each layer refines the vector more and more. Okay, so you can say that there are step 3 is happening multiple times. Okay, and with each repetition it improves this token. So together step 1, step 2 and step 3 is called encoding layer. Okay, what's the step 1? Again in quick, whatever the input text you give, broke it into tokens. The step 2 is whatever the tokens now you got from its vocab file, which is has the static embedding, take out what the exactly this model understand about this token. Okay, let's say that for example I gave some garbage which is there no token in this dictionary, let's say something XYZ. So what it will do is whatever the vector, whatever the nearest understanding, it will try to see that hey, whatever the nearest meaning of the token, similar token, nearest similar token, it will use its token. So it's not like if for some token there is no data in the vocab file, it will keep it empty. No, it will update the token, update the vector with the, you can say that with the vector of the nearest similar token, something. Okay, but you have some value, vector value for the token, even if you the garbage value you will provide. And during this step 3, where the contextual embedding from that static to contextual, it refined those vector values. I told you now how it refined. It give attention to its neighbor token and get a better understanding what this token might be. And for just testing, or you can say the learning purpose, I gave you this example where Apple has 2 different contexts in 2 different sentences. Okay, so this 3 step is known as encoding layer. Now after that decoding layer comes into the picture. What it will do is that it takes the contextual embedding as input, and its output is the next best possible token. So in short, what we are trying to do is we are trying to do prediction of next token in sequence. Okay, we are trying to predict the next token. Okay, so after encoding layer like this, we got for each token we have the contextual embedding. Now our decoding layer start. Okay, so in this it is try to find out what is the next possible token could be. Full stop could be, let's say, has probability 0.5, right? So different tokens like question mark 0.01, this has this probability. So maybe so many next possible tokens could be, each having its probability value. So it will pick one of the best or predict one of the best token out of that. So the next token, let's say it picked out of the so many which could be the next token. Let's say it picked dot, full stop. So what it does is, so Apple makes extraordinary phones. After that it append this full stop. And when it append this, yeah, how, so this is also a token, right? Full stop is also a token. So in its vocab file, it has the vector sequence for it, but it is static. Okay, so the same process repeat. Now you got this one token predicted. Now it repeat the process. It goes back to encoding layer. Now in the encoding layer you have what all the tokens. Apple makes extraordinary phone, full stop. Okay, now all this goes to the same layer. Okay, step 1, step 2, step 3. So you might be thinking that, hey, for Apple we have already done contextual embedding, why the same process we have to repeat it again? Okay, so generally it do cache for previously computed contextual embedding. So for Apple it will not do again contextual embedding processing. Okay, so but for this full stop, since its data is not cached, for its from static embedding, it need to generate its contextual embedding, and this process continues. Okay, so next time you have this for the decoding layer, full stop is also there, and it has its contextual embedding also, let's say 0.1, 0.2, 0.3 something. Now again it will predict what's the next token. So next token, let's say that Apple makes extraordinary phones. Let's say that next token would be especially. Okay, this is one prediction could be, let's say 0.03. Okay, next word could be, let's say iPhone, prediction could be 0.50 something. I am telling you, it will predict what could be the next word can come. And how it will predict this? Now we have the contextual embedding. Like it has certain info that, okay, what we are talking about, this Apple is regarding this company. Okay, we are talking about phones and all. So try to predict the next word, next token. That would be the correct term, not word, next token. And from that prediction, it will pick one. And once after that, it added. Let's say it choose especially. So it will add especially. Then from its vocab file, it adds its static embedding vector 0.5, 0.6, 0.7, 3D, let's say in 3D space 3. And process repeats again and again and again, and it's continuously like creating a sentence for us. Like initially it was like Apple makes extraordinary phone dot specifically iPhone, you must buy it. Like it's now continuously following this process. So now the question can come is that, hey, when it will stop? When it will stop predicting? See, it says continuously predicting what's the next word, what's the next word, what's the next word. And it is continuously generating this text on its own. Okay, but where to stop? So GPT has some predefined EOS, end of sequence. This is nothing but a special tokens, like let's say this is one special token. Okay, so whenever your next prediction comes this token, means you have to stop now. That is one way. Another way is that in API also we can set the max token limit. Okay, when the maximum token reach to 2000, then also you have to stop. That also we can do. So these are two different ways. There could be many, but these are two different ways through which we can stop this prediction process. And through this prediction process, you know that it comes automatically. It generates like a sentence for us. Okay, keep on predicting the next word, keep on predicting the next word. I hope if you read the documentation of transformer, you will see that it's not that simple which I told you. It is very complicated one, but I hope with this steps it might be little clear, and if you once go through this documentation, you will get more insight. Okay, what exactly they are talking about, and what internally more you can if it interests you more, you can go and learn more about it. So now we know a little bit about what is GPT and its architecture internally. You can say that transformer architecture. We can see that different GPT versions are present into the market currently. So we have, let's say, GPT X, let's say GPT-1, GPT-2, GPT-3, GPT 3.4, GPT-4, GPT-5. So these are text. These are text focused code capabilities they have, right? So these, you can say that GPT-X, now you can replace it with number. So all these are text focused, right? And also have certain code capabilities. Let's say GPT-4 has good code capabilities also. Now another version you will find is GPT-O. So like GPT-4o. Now you will see appended O, a small o. So these are known as omni or multi-modal, which not only support text but also audio, images, etc. So that's why it is known as multi-modal. Okay. So whenever you see with any GPT version appended O, know that it apart from text, it can also support more things. But if it has only numbers, generally it's text focused or code capabilities. And with any number, you will see GPT mini, like GPT-4o mini. Mini means there would be some trade-off with capabilities, but it would be very fast and it is small. So it could be cheaper also. Okay, it could be cheaper. It is small, it is fast, but the trade-off is with capabilities. For image generation, GPT has GPT-image-1. So it generates or edits the images, this model. Then for speech and text, like TTS, there is text to speech. Then we have Whisper, speech to text. So these are the models which we use for these two purposes. Then we have something called real time, GPT-real time. This is for optimized for WebSocket and WebRTC. So generally, if you see, these all above all are HTTP based. Means you provided a prompt to GPT, it works on it, compute the response fully, and then returns the response. But with the real time, like as it's predicting the word, it is also sending in real time also. So it's like connection is open and it is bidirectional. As soon as it is getting the new token, it's keep on sending it. So you don't have to wait fully for the response to complete. Okay. So for that we can use GPT real time. So these are the different versions which we can use while integrating our application with the GPT. Based on what application we are building, we have to decide which one to use. Okay. Now we can, I think with this basic understanding, we are all on same page, and now I think we are good to start with the project setup. So first thing is the prerequisite is Spring Boot. I think if you haven't seen the Spring Boot playlist, I would say that if you don't know Spring Boot, kindly go through it first, because since as the name says Spring AI, we will be using lot of Spring framework related terms and all. So I would say that prerequisite is your Springboot. Okay. And I will see you in the next part where we will complete the project setup. Okay. And if there is any doubt, let me know in the comment section. We can discuss further. Okay guys. Bye. Thank you.